Hello everyone, I am back with another MERN Stack interview question which is asked a lot of times in backend interviews as well as in full stack development interviews, which is what is libuv in Node.js. So whenever you come across any kind of interviews for Node.js, interviewers typically ask questions related to this like what is libuv in Node.js and how is libuv used to handle the event loop. So these are all buzzwords which you might have heard before, but most of us haven't heard of. So let's start off with the first question which comes to our mind is obviously what is libuv. Now libuv is a C++ library which is used internally by Node.js to handle all kinds of operations internally, like let's say IO operations, all the network requests which happen in a Node.js server, and all the file system tasks which happen internally in Node.js. All those are handled by this tiny library written in C++, which is libuv. Now, in order to understand how libuv works, we need to just go through briefly the history of how server used to work before Node.js was introduced. So the popular server which was introduced before Node.js and which was used a lot was Apache. Now, in case of Apache, what used to happen was whenever any kind of request was sent to Apache by a client, Apache used to spawn a new thread for handling that request. And let's say if there was any kind of call made to a database to serve that client request, then what Apache used to do was it used to transfer that database request, or it used to start execution of database request and it used to fetch data. But until that data was fetched, Apache used to block itself. That is, no new request was served until that request used to get completed. Now, this was one of the way in which requests were served using PHP and Apache. And the main disadvantage of this approach was until those database requests were completed, the Apache or the PHP server did not used to serve any other request. And this was kind of a wastage of resources because let's say the processor or the hardware on which the server process was running used to get blocked. And let's say this number of requests start increasing exponentially, then the amount of resources wasted by this blocking approach which used to happen was tremendous. Now, one of the improvement which happened in case of Apache was done in case of Nginx server. In Nginx, what they did was they introduced the concept of event loop. Now, what event loop is basically is, let's say if there is any request which is coming to, let's say, Nginx server, what Nginx server will do it will start the execution of request, like it will also try to fetch the data from somewhere, but it will store that request somewhere in a queue called as callback queue or event loop queue. Now, once that request was stored in the callback queue or the event loop queue, what Nginx server used to do was it did not stop for the request to get completed, and it used to move over to the next request from another client, and it used to resume its execution. Now, you might ask what used to happen with the first request which came from the first client. So what Nginx did was it used to store that in a queue called as callback queue, right? So once the execution from the database or the fetching part from the database was completed, what callback queue used to do was it used to see that whether the server was free at that time. And if it saw that server was not handling any kind of operations, that callback queue used to fire an event back to our server. And that server then used to take the data which was received from the database and it used to pass on the data to the request from the client from which it was received in the first place. So the blocking nature which was predominant in the PHP and Apache era was solved and it got replaced by a non-blocking nature. And that is basically how Nginx became a lot faster and it used to handle the request in a much better fashion and in much lesser number of resources. Taking inspiration from the similar mechanism which was introduced in Nginx, even Node.js creators wanted to use that event loop in Node.js as well. In order to use that event loop and that non-blocking nature in Nginx into Node.js, the Node.js creators integrated libuv in the Node.js core libraries. Now you should understand first what is libuv and how it works. So libuv is a library written in C++, and if you go to the GitHub part of libuv, you will find the entire source code and you will find all those features which are present. Now, if you see all those resources, they might seem like a jargon if you look at them at the first time. So what we can do is we can try to understand the core architecture of libuv. Now, I am at this blog called as docs.libuv, and here you will find the core architecture of libuv. So internally libuv is written in C++ and it has all these kinds of components. Now the first component that we see here is network IO, in which we have this TCP, UDP, TTO and pipe kind of components. Now these components allowed us to write or listen to asynchronous TCP and UDP sockets. This allowed us to have a non-blocking nature while serving requests, and also asynchronous nature was possible in DNS resolution as well. Other than that, the other components which were present was file IO. So let's say Node.js had to access files for some kind of request, or it had to read or write to the files. Then this file IO system was used so that Node.js could work across all kinds of different operating systems. So this file IO handled the file management across different OS on itself, and Node.js used to make a calls to this file IO. Other than that, we have a thread pool. So this thread pool essentially allows us to share all the requests along different amount of threads possible. Now let's say if we have a 4-core processor, then what Node.js internally does is it spawns 4 threads across all those 4 processors, and this thread pools allows us to manage or split those requests which are coming into Node.js across all those 4 threads. By this way, we are not just allowing the request to be handled in a non-blocking nature, but we are also allowing distribution of requests across all the cores or all the available hardware resources. Now, another thing which we are currently interested in are those green components, which is epoll, KQ, and event port. These 3 components form the core of a component which is called as event loop. Now, in order to understand what is event loop, let's go to the article by Node.js dev, which explains event loop in much detail. So let's say I have a function like this, like we have a function called as bars, which are defined in a function called as foo, and this foo is defined or defined using a console.log and those function calls, and it is called here. Now, in our previous video, we saw the call stack, which is responsible for execution of this code. So first foo function is executed, within that log function is executed first, or this log statement is executed. Then this bar function is executed internally, in which the log statement is printed, then bash function is executed, and then log statement within that bash function is executed. And after that, this foo function is taken out of call stack and it becomes empty. Now this was covered in another session. If you want, you can listen to that session to understand what is call stack in detail. But in today's session, I'm going to focus on another aspect of call stack, which is the event loop. Now in the event loop, what happens is in the iteration 1, when this foo function is called, not defined but called, when this foo function is called, this foo function is thrown into the event loop in the iteration 1, then the log statement within that foo function is executed, which is this one. After that, when bar function is called, then this log statement gets inserted into event loop. And when this bash function is called, then this console.log statement gets executed by the event loop. And as you can see, all these are iterations of event loop happening one by one, and that is how event loop execution works. Now, if you go into much more detail about event loop, and if you take the second example in which we have a similar case where function is called, but instead of calling the bar function, we have a set timeout here, and after the set timeout is complete, this bar function is executed, and after that bash is executed. Now in this case, what happens is set timeout is a function which has a timer, right? Now in case of timers, what happens is this timer is stored into the event loop, and once, let's say, this timer is complete, let's say this timer is set for 5 seconds, then what will happen is this set timeout function will be stored in the callback queue. And once that 5-second timer is complete, the event loop will check whether my core call stack is free or not. And if the call stack is free, then the data which is received from set timeout, in this case, let's say the set timeout is supposed to run this console.log statement, and an operation which is supposed to be run in from the set timeout is executed once the call stack is empty. So this is how event loop allows us to write asynchronous code. So the set timeout is basically making the code asynchronous. That is, after a particular amount of time, that data is supposed to be printed into the console. So that data is stored into set timeout method, and once that timer is complete, then it is printed into the console. So if you look at this example carefully, first the console.log foo statement is printed as shown. Then even if the set timeout method has a 0-second delay, still the log statement of bar is printed after bash. The reason for that is what call stack will do internally is it will first print this console.log as foo. Then once it encounters set timeout, it will store this bar callback into a callback queue, and it will continue the execution. That is, it will not stop for this set timeout method to get completed, even if it is for 0 millisecond as well. Then it will move on to the next line, and it will execute the bash function, and it will print bash first, because Node.js is internally non-blocking nature. That is, this set timeout, even if it was for, let's say, 5 seconds, even in that case, it won't wait for the set timeout to get completed. It will execute the bash function and it will print this bash statement here. Once that bash statement execution is complete, only then the call stack will get empty, and only after that our event loop gets a chance to execute this bash function and run the code which is present in my bar function. So only when this foo function has finished its execution, only then the event loop will see that yes, this call stack is empty, and after that only the bar function is added into the call stack, and that execution is completed and the bar console.log statement is printed. So essentially this is how Node.js has become asynchronous nature, and part of it has to do with event loop. And libuv is the library which allows the execution of event loop possible by its own internal components like epoll. So epoll is like a polling mechanism by which the polling for those all kinds of requests happen. Then kq is might be used for queuing all those events in the callback queue, and so on and so forth. So on broad level, if anybody asks us what is libuv in Node.js, so libuv is basically a library written in C++ which allows Node.js to run operations asynchronously or allows it to run in a non-blocking fashion. And that is one of the reasons why Node.js is used for handling server requests, because Node.js can allow us to handle requests asynchronously and it is not blocked by number of server requests. And that is how Node.js is allows to serve multiple number of requests in least possible number of resources, and it makes the memory consumption of Node.js server a lot lesser as compared to other kind of server services which are present. I hope now you understand what is libuv and how it works and how it allows Node.js to run asynchronously and in a non-blocking fashion. That's it for today's session. If you found this video useful, hit the like button, and if you would like to listen to more such sessions in the future, hit that subscribe button. And that's it from my end. Thank you and have a nice day, everyone.